Okay, 8.1 test review. 1, 2, and 3 ask you to find your least common denominator. So you have to factor your denominator. This one's already factored. We don't care about the numerator. This is a perfect square minus a perfect square. So x squared is x squared, 3 squared is 9, which brings us to x minus 3, x plus 3. So knowing that, this has an x plus 3, this has an x plus 3, that matches. But this has an x minus 3, therefore this needs an x minus 3. So my GCF, or LCD, is x minus 3, x plus 3. Okay, here, this could technically simplify to 2 over 15, but 6 doesn't go into 15, so 6 does go into 30, so we know 30 is my LCD. This has x cubed, this has just x, so I can give more x's, but I can't take x's away. So this can be x cubed, this is y, but y squared, so this can be y squared. So there's your LCD there. And again, we have to factor, so something squared minus something squared, x 4, x plus 4, so there's that. And then this, I need to do the x, a times c is 8. B is negative 6, so this would be negative 4, negative 2. So x minus 4, x minus 2. So they already both have an x minus 4, so we know that's part of my least common denominator. However, this has an x minus 2, therefore this needs an x minus 2. And now they both have an x minus 2. Now this has an x plus 4, therefore this needs an x plus 4. So now they all have LCD. So there's your least common denominators for this. Okay, let's look at number 4. So we are just simplifying each expression. We are going to, excuse me, so we're going to take out our GCF on this one. 4 does go into 12, so 4 is my GCF. And when I take that out, I'm left with 3x minus 1. And then I have a 5 GCF on the bottom, which leaves me with, remember you're dividing that out, and that leaves me with 3x minus 1 also. So now anything that matches cancels, and my answer is 4 over 5. Here is a complex fraction, so we are going to, complex expression either way. We have to have a single fraction over a single fraction. Well, y minus 2 is the same thing as y minus 2 over 1. And then in a different color, I'm going to draw the fraction bar in the middle for the division over this. So I need a common denominator. Well, 1 and y, this can turn into y by multiplying by y. So times y, and that became y squared minus 4 over y. So I know that this cannot factor at all, but this can factor the top. This is the same thing as something squared minus something squared, y squared and 2 squared. So I'm going to rewrite the top, y minus 2 over 1. I'm going to change it to multiplication, and I'm going to flip this guy. So I have y over, and I'm going to factor that. It becomes a y minus 2, y plus 2. So then I can cancel anything that cancels. Well, the y minus 2's cancel. And I'm left with y over y plus 2. Okay, there's number 5. Let's look at number 6. Okay. Well, again, we have to factor all the pieces. Here we're multiplying. So we're going to factor all the pieces. This is a perfect square minus a perfect square. This is x and 2. So that becomes x minus 2, x plus 2. This is also a perfect square minus a perfect square. This is 2x and 1. So that becomes 2x minus 1, 2x plus 1, times does not factor, so 2x minus 1 over x plus 2. You can put them in parentheses, you don't have to. And then we cancel anything that can cancel. So we have 2x minus 1's cancel, x plus 2's cancel, and we're left with x minus 2 over 2x plus 1. Okay, let's look at number 7. So we have to find our least common denominator because we're adding, and to add or subtract, they have to have a common denominator. Well, they both have a y, so we're good there, but 4 and 5 can both turn into 20. On this side, you're going to multiply by 4. On this side, you're going to multiply by 5. And I know that my common denominator is going to be 20y. So 5 times 1 is 5, plus 8 times 4 is 32. And that leaves me with 37 over 20y, which does not simplify. You can use your calculator and check it. It does not 32, sorry. I said 37. I wrote 32. 37. I'm going to rewrite it. And that does not simplify. That would have if that was right, but it's 37. That's because that's a 32. Okay, look at number 8. Here, again, you want to treat these just one half at a time. So let's look at just the top half. So here we have over 1. We need a common denominator of just x. So times x. What you do to the bottom, you have to do to the top. And this now has a common denominator of x. And we have 7x minus 3 on top. Okay, now on bottom we have over 1. Again, times x, and we have 3 plus 7x over x. So I'm going to rewrite it. The top is correct, so 7x minus 3 over x times, flip the bottom, I have x over, now this is backwards, so I'm going to rewrite it in the right order. They're both positive, so it's okay, positive, so we have 7x plus 3. Well, the only thing that cancels here are the x's, and we're left with 7x minus 3 over 7x plus 3, which are not the same. One's minus, one's plus, so you can't cancel any of it because that plus and minus makes it stuck like glue. So there's your answer. 9 has a plus sign, so we need a common denominator. I need to factor the bottom. A is 1, so I can just do the x. A times c is 2, b is 3. 1 times 2 adds, this multiplies to 2 and adds to 3, so this becomes x plus 1, x plus 2. So they both already have the plus 1. This has an x plus 2, therefore this needs an x plus 2. And this has a 2x minus 3, therefore this needs a 2x minus 3. And there's a plus in the middle, so we don't have to worry about that. So we're going to distribute. So I'm going to bring my common denominator down here. And I'm going to ignore that. I'm going to simplify just the top over here. So x times 2x is 2x squared. X times negative 3 is negative 3x. Positive 2x times x is positive 2x squared. 2x times 2 is 4x. Well, these are like terms, so 2x squared plus 2x squared is 4x squared. Minus 3x plus 4x is plus x. Well, that has a GCF of x, and I'm left with 4x plus 1. Well, nothing simplifies. So there's your answer. If you would have left that in, that would have been fine, but just realize that those are the same thing. Okay, look at number 10. Here is one of the ones that confuses y'all because they look the same, but they're not, because x minus 1 is a positive x minus 1, negative 1, and this is a positive 1 and then negative x. So when I reflip this, I get this, and I have to take that negative out. Oop, and I get minus, dang it, and I get, when I take it out, that's like divided by negative 1, and I get x minus 1 on the inside. So to make these match, I have to get this a negative in the front, top and bottom. 2 negatives makes positive, so it's still positive. And I have negative x plus 1. Well, again, I could take that out. And I have the same thing divided by the same thing. Well, anything divided by itself is 1. Because the double negative makes a positive, and those cancel. Here I have a GCF of 2. That leaves me with 2x minus 3. Here I want you to realize I have a perfect square minus a perfect square. So 2x and then 3 squared. So that leaves me at 2x minus 3, 2x plus 3. And the 2x minus 3's cancel. And we're left with 2 over 2x plus 3. "12 is ugly, but we know that whenever you have this, it's on the wrong side of a fraction. So I need to make it a fraction, I need to move it. And I'm going to rewrite that over here, and I end up getting p to the first power plus q to the first power, and you can't leave the top empty, so that becomes 1. Over here, over 1, so the whole thing moves, and you get 1 minus 1 over p to the q, because that moves down, and then the top can't be empty. Well, this has a p, therefore this needs a p. This has a q, therefore this needs a q. And that becomes q plus p over pq. And then this has a pq, therefore this needs a pq times pq. And this becomes pq minus 1 over pq. I'm running out of space, so I'm going to squeeze it. So I have q plus p over pq times, flip the bottom, pq over pq minus 1. Those do not match, so they do not cancel. So we have q plus p over pq minus 1. There's your answer. Oop. Alright, flip to the back. Here they already have like terms, like denominators, so that's nice. We need to distribute that negative though. So we have x plus 1 minus 2x. 2 negatives makes a positive 1. So that gives me negative x. 1 plus 1 is 2. Which you can leave like that, or you can take the negative out and it looks like this. So those are the same thing. Here we need an LCD. 4 and 6, 6 can turn into 12, 4 can also turn into 12. So this would be times 2. This would be times 3. Now this has a squared and this doesn't, so this needs another x. So we have 12x squared as our common denominator. And I have 6x plus 3. And I want you to realize there's a minus, but I'm going to distribute the 2x first. So 2x squared plus 6x. But I have to distribute that negative. So this also becomes minus 2x squared minus 6x. So the 6x cancels. And I have negative 2x squared plus 3 when I write it in order. You can take the negative out, but it doesn't change anything. You can't take out a GCF, so nothing simplifies, so there's your answer. Okay, look at number 15. This is times 2 because 7 can turn into 14. They both already have an x. So I know 14x is my LCD. That gives me 24 minus 3. Which gives me 21 over 14x, which does simplify because 7 can go into both of those. So you could always alpha y equals enter, 21 over 14. Don't type the x, and it'll be 3 over 2x. Okay, look at number 16. Here is division. So we have to factor all the pieces, something squared minus something squared. That's a perfect square minus perfect square, x squared and 1 squared. So remember, the first fraction stays the same, x minus 1, x plus 1, over 2x plus 1, x minus 1, change it to multiplication and flip, but we're going to factor both pieces. So again, perfect square minus perfect square, x squared 2, so that goes on the bottom, it becomes x minus 2x plus 2. We have to do the box for that piece, so I'm going to come up here where I have a little bit of space. A is, B is, C is, so 2, negative 3, negative 2. 2 times negative 2 is negative 4. B is negative 3. Negative 4, positive 1. 2x squared, negative 2, negative 4x, positive 1x. So 2x plus 1x minus 2. So now we cancel x minus 2, x minus 2, 2x plus 1, 2x plus 1, x minus 1, x minus 1, nothing else, so we are left with x plus 1 over x plus 2. Then we have 17. Again, 2 of the pieces are already factored for you. This is kind of how it would be on the test. You have to factor the other 2 pieces. Both of them have a as 1. So a times c is 3, b is 4. So 1 and 3. This becomes x plus 1, x plus 3. Over here we have a times c is 6, b is 5. So it's going to be 2 and 3. So I'm going to rewrite it. X minus 1. X plus 2, x plus 2, x plus 3. I don't like canceling anything until I have the whole thing factored and written down. Some of y'all start to cancel things and then you kind of throw yourselves off too early, or you might forget and rewrite something even though you shouldn't have. So I wouldn't cancel until you have everything factored. So x plus 2's cancel, x minus 1's cancel, x plus 3's cancel, and your answer is x plus 1 over x plus 4. Here's a division problem, and we're going to have to factor the first half. This half does not factor. Here we do have a GCF, so when I take that out, I'm left with x squared minus 25, which is a perfect square minus a perfect square of x and 5 squared. So this became 3x minus 5x plus 5. Over, that has a GCF of 6, and when you take that out, you're left with x minus 5. Change it to multiplication and flip x plus 1 over 4x. Well, x minus 5's cancel, and that's it. So I'm left with, I want you to realize 6 can turn into 2 times 3, so these 3's can cancel. On top I have x plus 5, x plus 1. Over 2 times 4 is 8, and there's still an x. Could have used your calculator, but I didn't feel like it. Okay, last 2 problems are domain. Remember the domain, it's okay to have a 0 on top. It is not okay, no, on the bottom. So this one's already factored for us. Remember, you can ignore the top. It's what makes your denominator equal 0. Well, you can separate and set them equal to 0 and solve, or you can just look at them. What gets rid of a negative 1? Well, a positive 1. What gets rid of a positive 4? Well, a negative 4. So x cannot be negative 4 or positive 1 in this problem, because if it is, that would make the denominator equal 0. Now this one is not factored for us, so we have to factor the denominator. Remember, we don't care about the numerator. A times c is 6, b is 5. It's going to be 2 and 3. Well, what cancels a positive 2 and a positive 3? X cannot equal negative 3 or negative 2. But again, you could have separated and set equal to 0 and solve. So minus 2, x equals negative 2, minus 3, x equals negative 3.